recording, okay, and going to share screen. So today we will, hold on, okay, admit. Okay, so today we will have a new topic. So we are going to discuss ensemble learning, okay. Previously, what we discussed is just some single learning algorithm, etc. And ensemble, we are going to see you can combine multiple learning algorithms together. Okay, but previously, if you recall, we also learned like the grid search, is it? But in that regarding, as you trying to pick the best algorithm, the learning method, is it? That's the grid search one. So that's different from this, okay? And also, plus you can pick the best hyperparameter tuning, etc. with regarding the grid search, okay? So today is about ensemble learning, okay? So let's see what it's about. So it's combined, it says different models, is it? Different models. And over here it says the cause of error in all of our previously discussed learning models, is it? Can be due to noise, bias, and variance, is it? And the ensemble learning is try to minimize those factors. Okay, so here again, okay, you remember previously we learned the bias and the variance, is it? So if it is a high bias, what kind of problem it can lead to? Who still remember?
I think overfitting. Oh,
Higher bias.
oh,
Higher bias. Yeah, it's underfitting. Okay, remember this. Underfitting. Very good. But you two can both get a bonus point. Just send it to the chat. Okay. So higher bias lead to underfitting. Okay, underfitting. And high variance lead to what?
no, overfitting.
Yeah, overfitting. Yeah, very good. Okay, you can send it to the chat. Okay, that's overfitting, is it? So keep those two in mind. Okay, bias and variance. Okay, keep those two in mind. Which one lead to underfitting? Which one lead to overfitting? Okay, so keep those in mind. Okay, so that's just a quick recall, okay. And here ensemble learning says it's construct a set of classifiers, okay. And they can often have better predictive performance than any of the individual members, okay. And if you recall, do you recall so far among what we already learned learning algorithms, which one kind of have a group of learning algorithms working together? Not a different one, but the same one. Do you still remember? Not a single, not you just apply the single learning method, single model to the whole data set. You can apply
dimensionality.
Pardon me?
For dimensionality?
I didn't quite get it. You remember it's regarding the tree. Do you still remember? Who remember that? Regarding some kind of tree. Regarding some kind of tree, who remember that? Regarding some kind of tree. Random what? Yeah, random forest. Yeah, okay. So remember, random forest, it doesn't use a single decision tree, is it? It uses multiple trees, is it? So random forest at a certain point, okay, certain level, we see it also belongs to ensemble learning, is it? Okay. And if you have multiple, like a random forest, you have multiple decision tree, is it? You have multiple single decision tree. Then how do you make your decisions? Each one give different result, maybe, is it? So how we make decisions, it's based on the concept is called majority voting. Okay, so keep this in mind. That's based on majority voting. Okay, and here says we can use bagging, and later on we will see. Okay, so bagging to reduce overfit. Okay, so bagging is to reduce overfitting. Okay, as by drawing random combinations of the training set with repetition. Okay, so over here we will learn, generally speaking, two basic approaches. One is called bagging. What is bagging? It's two words abbreviation. Okay, the other is boosting. Is boosting. Okay, so bagging to reduce overfit is to draw random combination of the training set, but allow repetition. Okay, so what does that mean? We will see. And the boosting is starting with weak learners. Okay, and then it try to reinforce with some weight. Okay, so that's why we call it boosting. Okay, so that's the idea. Okay, so this is just some general concept. Okay, very general. Okay, so here is some simple ensemble techniques. And the first one I discuss is about mode. Okay, so what is mode? It says mode, it refers to what? It's some statistical term, refers to you use most frequently occur number found in a set of numbers. So that's what mode means. Okay, and so it's based on most frequently occurred items. Okay, so the predictions consider separate vote, is it? And we get the majority of the models as the final prediction. Okay, so this is what the mode. And the average is you have the result from all of that and you average it. That's quite easy to understand, is it? And the weighted average is you not treat everyone the same, is it? You have some models get more weight and the others get less weight. Okay, so that's why we call it weighted average. Okay, so this is just some simple ones. And advanced, okay, so here we have the word bagging. So bagging, what it comes from is from bootstrap, okay, aggregating. Okay, so it has aggregating as it, but it has bootstrap. Okay, so what the idea is, you have, so like over here, you have observation. So that's your whole data set, is it? Your whole data set, is it? And then you pick some training subset, is it? So you build, construct a different training subset. Is it training subset? This is also, you remember previously, we also learned K-fold. Is it? K-fold can, the cross validation, is it? But the purpose over there is validation. Is it the cross validation? And it's also helpful to reduce overfit, is it? So over here, it's a different strategy, is it? And you divide the data set into different training subset, is it? And then for each one, you use either the same model or you can use different models, is it, to train, is it? And then you can do prediction, is it? And with the predicted result, you do what? We aggregate together. How do we aggregate? Like you can use like the majority voting, is it? So that's the idea, okay? So this is bagging, and the second major approach, like we said, is called boosting. Okay, boosting. So for boosting, the general idea, like over here, it shows you have the original data set, and then you do the training. Is it over here? We call it weak learner. So you start with weak learning, is it? And of course you have some arrows, is it? Like over here shows the orange dot is the arrow. And but because of those samples, so those samples have arrows, is it? Predicted erroneous, is it? And what you are going to do is in the next set of training, iteration of training, is that you are going to weight them more. Okay, so add more weights. Add more weights, is it? So that's why we call it boosting. Boosting, okay. So that's a general idea, okay. Okay, so learning with ensembles. Okay, so we will followed by the majority voting principle. Okay, it says most popular ensemble methods. Okay, but majority voting principle applies to binary class setting. Okay, so be careful this. For multiple classification, is it? Then we need to use, it's called plurality voting. Okay, it's not majority voting. Okay, so that's about ensemble. So here, let's see. Okay, what what is the idea about the bagging? Is it a kind of concept? So we have training set, is it? And then you have different classification models, is it? For each of it, you can apply different training data set, is it? And then you make a prediction, is it? And then for final prediction, is it? Because you use multiple models, is it? And previously we learned is that you can do mode. You can also do average. You can do weighted average, is it? And we can also do majority voting. Is it? So over here you can do majority voting. So this is one kind of idea. And stacking algorithm, it will be one of your assignment. Okay. And then let's see bagging. Okay. So bagging, we already said it's boosted, not boosted, it's bootstrap. It's bootstrap aggregation, aggregating. That's why we call it bagging. Pick the B, is it AGG and ING, is it bagging? Okay, so it's bootstrap aggregating, okay, aggregating. And it says it's closely related to majority vote classify, okay. And what is bootstrap aggregating? So it's the samples. It does bootstrap samples. So bootstrap samples is what? Is you random pick the training set. You are not going to use all of the data set, training set. So you're going to pick part of the data sets, okay? But be careful, okay? You will allow replacement. So some samples may appear multiple times. Okay, so that's what we call bootstrap samples. Okay, random but allow replacement. Okay, so that's the idea. about, so let's see here. It may make more sense, is it? So here it shows what over here is sample indices. Okay, so basically it's indices, is it? Okay, sample 1, sample 2, sample 3, sample 7, is it? And it says bagging round 1. As if you take a look, the second one, is it second sample repeated 3 times? Is this, so that's what we call, but you pick, you randomly pick. Randomly select. Is it randomly select? Is it, but allow replacement. Allow replacement. Is it, so the second one repeat multiple times. Is it same thing for the second rounding? Is it the first one repeat multiple times? 7 also repeat multiple times. Is it so? This is a general idea about bagging. Okay. Okay, then about boosting. Okay, so just some general idea. Okay, so boosting is what? Boosting is because it's focused on the error predicted one. So erroneous predicted samples. Predicted ones. Okay, that's its goal. Okay, so focus on training samples are hard to classify. Is it beginning learnings? We call them weak learners. Okay, and then later on, you will learn from misclassified training samples to improve performance. Okay, so you will put more focus on previous training that's misclassified. Okay, so that's what we call it boosting. Okay, so we just needed to get a kind of the basic concept here. Okay, how, here's, it also says how boosting works, is it? So initially, you just random select some training samples, is it? But here, be careful for boosting, it's without replacement, okay? Not like bagging, is it? It says, okay, you draw some random sample without bagging, without replacement, is it? And we train the learner, we call it a weak learner initially. Is it apply some learning method? Is it? And we call it a weak learner. Okay. And then we start with the second round. Is it? And you still draw some random subset D2. Is it without replacement? At the same time here, be careful, you also add 50% of the samples in the first round that misclassified. Okay, so in your second round of training data set, this is second round. You add 50% of misclassified from first round. So from D1, basically. This is D2. Is it D2? Okay, that's why we call it boosting. Is it boosting? Because the erroneously predicted samples got trained for the second round. Is that for the second round? Okay, so that's the idea. And then says for the third round, is it D3 in the training set? Is it? Then you will find the first and the second round among all of the training samples. If they don't agree, then you will add them to the third training. Okay, so, and the last, you're going to use majority voting to get combine all 3 learners, is it, to find one. And one of the boosting method we use a lot is called adder boosting. Okay, adder boosting. Okay, and the other one is, we were seeing our example, is called gradient boosting. Okay, So those are general idea about boosting, okay? And basically that's all for the general idea. So next, let's see the example, okay? Okay, the first example is also from the UCI. Okay, that's one of the classic machine learning data repository. Okay, UCI machine learning repository. And this is regarding letter recognition. Okay, it's a build a model, okay, of for the images of 4 letters. Okay, A, B, P, R. Okay, and previously we learned this. Who still remember what is this? MNIST. That's also one of the most classical data set. Who remember what is MNIST is about? MNIST. Who remember that? It's about what? Who still remember that? Okay, let's see the chat. Okay. Yeah,
Data set for
handwritten digits.
images.
Yeah, very good, very good. Yeah, handwritten digits image, is it? So it's the simplest. It's like image recognition, hello world, is it? 29, is it 10 digit? Okay. Over here, it's about some alpha letter, okay, ABPP. That's what this data set is about, okay. So let's see. And it's import models, logistic regression we learned, is it? And the train test split, we also already learned. Confusion matrix, classification report. Okay, another question. What is confusion matrix used about? Who still remember? Confusion matrix is used for what?
We can get the true positives and true negatives.
Yeah, very good, very good. And what's the overall purpose for confusion matrix?
We can calculate recall and precision.
Yeah, yeah, very good. Okay, you can get send your answer to the chat, is it? And yeah, so confusion matrix is true positive, is it? And negative positive, is it? True negative, and negative negative, is it? So that's regarding confusion matrix. And it's part of performance evaluation, is it? Evaluation, is it? Performance evaluation, we learned generally we use what to measure performance? So performance metrics.
Generally, it's accuracy.
Yeah, generally it's accuracy, is it? And confusion matrix can also be used to measure performance, is it? And regarding that, what we have? We have some, we call it.
Okay.
Precision.
Yeah, very good. Precision, recall, and what kind of score?
F1 score.
F1
yeah,
score.
F1 score. Okay, so keep those in mind. That's also help for performance evaluation, okay, for machine learning. Okay, decision tree, we already learned, is it? And generally speaking, for decision tree, do you need for data pre-processing? Do you need to do data normalization or data standardization? No. Yeah, very good. You can send your answer, okay, to the chat. How about SVC? Generally speaking, do we need to do data normalization or data standardization? SVC is what? Is support vector machine.
Yeah.
Yes, okay, very good, yeah. And today we learned ensemble, is it? We are going to learn ensemble, so we can import, it's called voting classify, okay, we will see. And the model selection, and we learn ensemble bagging, is it, bagging? And the random forest we already learned, is it? So those are regarding the models, okay. And over here, we have that CSV file, is it? And we import that CSV file and we take a quick look of that data, is it? So there are a lot of columns, is it? And you can see it's identify the 4 letters, is it? That's our goal, okay? So we only collect all of the data within those 4 letters. Of the others, we filter them out, okay? So that's what those part. And then we use the values, is it, to have the feature space and the target value. That's always what we do. Then we do train test split, is it? So nothing new here. And the first we do logistic regression, is it? And then we do fit and we do predict, is it? We can get the confusion matrix and classification report. Is it? Did you see? Here it shows precision, recall, and F1 score. Is it? And the result is not too bad. Is it? Okay. So that's about logistic regression. And what next we are going to do is we are going to do the bagging. Is it? So we are going to learn, we are going to see bagging. Bagging is what? Is B represent bootstrap. Okay, remember this. AGG is aggregation. Aggregating, is it? And over here is aggregating and ing, is it? That's bagging, okay. Keep that in mind. The first, what we do, we are going to apply a k-fold cross-validation, is it? So that's why over here, we set up a k-fold model, is it, with 10 splits, is it? Okay, then we do bagging classify, is it? For this bagging classify, the base estimator, we use what? We use decision tree, is it? And how many trees? 100 trees. That's huge, is it? A lot of trees. So definitely this is ensemble, is it? You have multiple trees, okay? And then based on this, after the bagging, is it? And then did you see the bagging is this model 1, is it? And then for bagging, then we do what? Cross validation, is it? And we use that fold. Okay, so over here, you see it's quite comprehensive already, not like previously we learned just a single learning algorithm, is it? Over here, we also integrate the k-fold cross-validation, is it, with our ensemble learning, is it? So ensemble is just part of the learning, is it? Part of the learning. And we also apply cross-validation, is it, to try to improve the performance, okay? So with this, we can then find, you see over here, we collect what? We collect the average result, is it? So it's not bad, is it? It's 97, the accuracy. It's pretty good, okay? So this is regarding bagging, okay? It's pretty simple, is it? You can see this, is it? And the next is random forest, is it? We already learned, is it? Random forest over here, similar, is that you can also do k-fold and then random forest, is it? And the cross-validation, is it? And the result is 98%, is it? Okay, and what the next one show is about boosting. Okay, boosting. And over here, what we are going to learn, the first one is ADA boosting. ADA boosting. Okay, ADA boosting is adaptive boosting. Okay, adaptive boosting. Okay, and it focus on what? So it's focus on convert weak classify. Okay, to strong one. Okay, to strong one. So that's its goal. Okay, that's its goal. Okay, then let's see. And you will see with sklearn, it's also quite, the line of coding is also quite simple, okay, not that complicated. So you import, add a boosting, is it? And here, same thing, we are also going to apply cross-validation, is it? And within the 10 folds of cross-validation, each one we are going to apply add a boosting. Is it adder boosting? Okay. With the adder boosting, we also do, so the base estimator, if you, because over here we didn't specify the base estimator, is it? It's going to be decision tree. You can also apply others, is it? And the whole, over here says decision tree, okay? And use 30 trees here. And then we do cross-validation, is it? And the result is not as good as previously with the bagging, is it? So compare with bagging, it's not as good. It's 85%-ish, is it? So this is adder boosting, okay? And what the next one is gradient boosting. Stochastic gradient boosting, is it? Who remember, generally speaking, in machine learning, what's the purpose for stochastic? Because you see this a lot, is it? So what does we already stochastic mean? Stochastic. Who remember that? We sometimes also call it online learning. Stochastic learning, sometimes we call it online learning. Why we want to have this? Do you still remember? Versus offline learning. And we call it what? B batch. Is it, if you recall, stochastic is online learning, is it? So it doesn't do, because you remember previously when we discussed the weight, is it? We use the summation of all of the samples, is it? All samples. Regarding all samples, is it? With gradient descent. Is it with gradient? Is it? A gradient is based on what? It's more focused on loss function, the cost function. Cost function, is it? And if you do batch, it's what? It's the whole data set. Then you do that summation, is it? The loss calculation, summation, is it? It's what? It's the versus the predicted, is it? And you sum of them, is it? That's, but a lot of time your data set is too huge and your machine may not that powerful, is it? Your machine can only probably processing part of it, small subset of the whole samples, is it? in that case, we use stochastic. Is it? We call it online. Is it? It can even do what? Mini batch. Is it? Or one by one. Is it? Each one, then it will do the update. Okay, so that's okay. So let's keep this also in mind. Okay, you also keep because when you go to job interview, people ask is stochastic. We should know what does that mean. Okay, it's mainly because for machine learning, when you have huge data, is it a lot? Then if you cannot load all of the samples to the memory, is it at one time do the processing? What can we do? Is it then with each one of it? Is it and you can do some gradient descent processing? Is it that's called stochastic? Okay. So versus adder boosting, gradient descent, and over here we are going to see it's gradient boosting, okay, versus adder boosting. Adder boosting is adaptive. Is it adaptive? So it's weak learners to, you train weak learner to strong learner. That's your focus. Is it? That's your focus. Gradient boosting. Is it? Gradient boosting is, it's not on the weight. Focus is not on the running doing samples. It calculate about loss. Okay, because gradient is a gradient. It's regarding cost function. Is it? So it use some loss to do the justification, okay, about the wrong erroneous samples. Okay, that's how it does. Okay, so that's the difference between adder boosting and gradient boosting. Okay, but anyway, in sklearn, it's pretty similar as over here. We first do k-fold, and then you just call gradient boosting. As this time, we use 100 decision trees. Is it like a random forest? Is it? And then we do cross validation. Is it? As a result, you see it's also pretty good, 98%. Okay. Okay, so that's about gradient descent. And then what the last part shows is about voting ensemble. Okay, voting ensemble. So all the previous one, what we discussed is using single learning algorithm, is it using decision tree, but you can allow multiple trees to do ensemble, is it? But ensemble is not just that case. Ensemble you can also allows multiple learning algorithms work together. Is it? Work together. So that's what over here we are going to see. Okay. So let's see. So we still do k-fold. Okay. So nothing new here. And then over here, see for our estimator is it? We are going to build an estimator list. Is it? The first one we use is logistic regression. Is it? We append it to this list. Is it logistic? And then we use decision tree. Is it? And we append it to the estimator. And then we apply support vector machine. We append it to the estimator. Then did you see for the voting classify, what it can take is a list of learning modules. Is it? Learning models. Is it? The estimator is a list. in this case, it support logistic regression, decision tree, and support vector machine. Is it? And then it does cross-validation. Is it? Cross-validation. And then you can find its average. And here we use its average accuracy. Is it? And the average accuracy is also around 98%. Is it? So not too bad. Is it? So voting classify, if you wanted to use multiple different learning models, you can also use voting classify, okay? Because, and what you can plug in is a list of learning models, okay? And regarding k-fold cross-validation, is it cross-validation? Is over here, it's a 10-fold. Is it? If it is 10-fold, you're going to do what? Iterate 10 times. Is it? Iterate 10 times. So you will have like the first fold, second fold. Is it? Or not? First round, second round, 10 rounds, 10 iterations. Is it? And within it, you will have 10 what? 10 folds. 10 folds. Is it? And generally speaking, is you have 9-fold. 9 folds. Do what? Do training. Is it? And 1 fold for validation. Is it? And this is all regarding your training data set. Training data set. Training data set. Is it? So over here, we have multiple. We have the ensemble learning. Is it? So for each round, you will apply the ensemble learning, is it, to each of this iteration. Okay, and for the data set, is a training data set, then you have training and validation for the ensemble learning also. Okay, so that's the whole idea about you integrate. We integrate also the k-fold and ensemble together. Okay, that's the idea here. Okay, that's this example we are done. And then let's take a look at the second example. Okay, and the previous we already see majority voting, etc. And we already see this. How do you do bagging, etc. Bootstrap with replacement, we know that. And over here, the example is regarding that wine data. We already saw that applied in our previous learning methods, etc. And we get the data. And over here, who still remember what this is used for? Label encoder. Who remember that? Label encoder is used to deal with what kind of data? Used to deal with non-numerical data, etc. So, okay, so keep those in mind also. And then do testing, training, split, nothing new. Okay, over here we do bagging, is it? And you first have decision tree, is it? And you specify the criteria, is it? And then when you apply to the bagging, is it, you can specify the base estimator. Okay, is this decision tree, is it? And the number of trees you want to have, is it? And then you can also collect accuracy, is it? So we already know this, is it? Regarding over here, checks regarding single tree and the bagging, is it? And you can see the difference. With single tree, it's 83%, and with bagging, it can reach about 90% is the decision. Okay, and then what is the next one? So this is just draw the contour, okay, with two different types of learning method. And the boosting, okay, so let's see. So regarding this boosting, the general idea over here, it also shows, is it? So you have a regional data set, is it data set? And this is the first round of training, is it? And we see these two misclassify. Misclassify, is it? And then in the next round, what you are going to do, did you see? We increase their weight. Increase the weight, is it? And of course, you still have something wrong predicted. Is it like this three wrongly predicted? That's why in the next round of training, you're going to increase its weight. Is it? So you see, this is the first round we call weak learner. This is weak learner. Is it? So you keep adding strength of the weak learner. Then you have the final strong learner. Is it? And everything, most of the samples can be predicted correctly. Is it? So that's the whole idea about boosting. Okay, boosting. And for boosting over here, says, okay, we do the adder boosting, as we use the base one decision tree, is it? And the accuracy it also shows, is it? And it's pretty similar as the previous one, bagging one, is it? And also did the contour, okay, the drawing. So that's, so today what we discuss is those two focused on the ensemble learning with the two different approaches. One is bagging, the other is boosting, okay. So that's all